So IgY is an antibody from egg yolk. It's found in the egg yolks in birds, reptiles, and amphibians. And its principle is like to know about its structure, its unique structures, and also its function. Like other antibodies, IgY is the part of the immune system and plays a crucial role in identifying and neutralizing the pathogens such as bacteria and viruses.
Hello and welcome to the Pet Food Science Podcast brought to you by Wisenetics. I'm Jan Sugodolski. I'm here at Texas A&M University and I'm dedicated to bring you the latest insights and discussions into what is new in the pet food science industry. So get ready to expand your knowledge and stay ahead with today's episode. And I'm really very much welcome today Shofiqur Rahman, who joins us from Japan today, this morning. Good morning to you. I'm here in Texas afternoon.
Good morning, Jan.
And Shofiqur is going to tell us today a lot about IgY. It's a really new, exciting technology that we're going to use, that is now used in pet food potentially. And then, so we're going to talk about this today. But Shofiqur, or Shofiq, that's what I can call you, is tell me a little bit about yourself. One thing I want to always know what is your current position, but also interesting for our audience is how did you, what was your career path? What are the major stages, and so you ended up in your position that you are now?
Thank you very much, my most respected professor, Dr. Jan Sugodolski. Thank you for inviting me. Really, it is my great pleasure being here today. Therefore, I'd like to express my heartfelt gratitude to podcast organizer for kindly allowing me to discuss about IgY technology, egg antibodies for companion animals. I also want to convey my deepest gratitude to my most respected audience worldwide for kindly listening my show. I strongly believe after this podcast show, my beloved audience will be very happy and become overall masters about noble IgY technology and its future direction for the well-being of animal and human in this universe through One Health program.
So tell us a little bit about yourself. So your current position and your career path.
Thank you, Jan. My name is Shofiqur Rahman. I am a microbiologist focused especially on microbial enzyme technology. I did my Bachelor of Science and Master of Science in Bangladesh in microbiology, and thereafter I achieved Japanese government scholarship for fulfill my PhD. I did my PhD in Gifu University, Japan. Then I joined Immunology Research Institute in Gifu. In short, it's called IRIG as a researcher. For your kind information, IRIG is supported by EW Nutrition. Since joining IRIG, 20 years already passed. My focus has been on the research and development of IgY for human, animal, and environmental health. In fact, I started my journey of research and development since 1991 with stints at pharmaceutical company and the Governmental Institute of Public Health. In total, I have a 33 years experience of research and development work in various roles, including R&D, quality control, production, and immunology department. This experience has given me the solid understanding of research and development in this biohealth sector.
A longer, healthier lifespan for our pets. That is EW Nutrition's target. With immunoglobulins, that target is within reach. IgY are a young generation technology platform, an innovative solution that has been tried and tested over the last decades and can now yield tangible benefits. Immunoglobulins from egg yolk improve the animal's response to pathogens in the gut or in the mouth. They're easy to administer, they're perfectly safe, and they just work. Made with passion, proven with science.
So tell me about IgY. What is the principle? And then we're going to more go into history, production, and so on. But what is IgY, and why is it really so exciting?
IgY is coming from its literal word. I will explain. I stands for immuno, G stands for globulin, and Y stands for yolk. So IgY is an antibody from egg yolk, and it's found in the egg yolks in birds, reptiles, and amphibians. And its principle is like to know about this structure, is unique structures, and also its function. Like other antibodies, IgY is the part of the immune system and plays a crucial role in identifying and neutralizing the pathogens such as bacteria and viruses. So if we look for is the history of IgY, it has a long history, which started from 1893. This concept of the passive immunity is reported by Klemperer, and in 1969, Lesile and Clems coined the name IgY. So why it is exciting? Actually, it is related is unique mode of action. So let me explain some example. That IgY, the first role of its action is inhibition of the bacterial and viral adhesion to the host cell surface, suppression the bacterial colonization and viral cell-to-cell spread. There is no invasion. Then bacterial agglutination, resulting in the microbial immobilization, fixation as a cluster, then being flushed out of the body. Then not only the bacteria and virus, it also inhibits the enzyme. That is also one source of the pathogen, the disease. And its another mode of action is other pathogenic factors, that is toxin. It can also neutralize the toxin. The overall, the IgY mode of action is showing as an immunomodulator in the mucosal cell line, mucosal area, in systemic area. So it is giving extra immunomodulatory effect on the host. So why it is so exciting? We can add some more example to explain this. That is, the source of the antibodies is coming from the chicken. So it is the non-invasive production of the IgY easily. Also, it is the exciteness. There is no need to killing the bird like the mammalian IgG. And another exciting is that it's the unique properties of function is species specific, and there is no binding to the mammalian Fc receptor, which is very important because it triggers the inflammation and is taking the energy from the host. So it is reducing the non-specific reaction. So this is the important things. Another one is application in the medicine, research, feed and food, and also is used for diagnostic purpose. The last but not least, it is also used as antibiotic alternative in agricultures and other livestock and swine production. We can reduce the or proper use of the antibiotic by the complementary using of this IgY. So that means IgY provide the passive immunity to help the animal stay healthy.
No, that's great. So maybe just so passive immunity, was it for specific diseases or specific infectious diseases, or is it just a general? How is it used in the past?
Passive immunity is one technique, that is the transferring the immunity by producing against a specific pathogen with a specific antigen. This is the passive immunity. And the passive immunity by IgY is done by the oral administration, which is called the oral passive immunity. So we learn this concept from the nature, because when the mom, either from animal and human, the baby born, new baby come in this universe, the first food is coming from the mom's breast milk, which is also the concept of the passive immunity, that is, mom is transferring the IgG to the baby for protecting. The immune system is very, very weak at the time. So in case of the mammalian, but in avian, how can protect the chicken also producing the same immunoglobulin, but deposited in the egg yolk to protect the chick. This is also the passive immunity concept. So this is the concept, the passive immunity we are learning from the nature, and we are protecting the nature. So yeah, this is in brief the passive immunity.
That brings me to the question about production, right? So if you want to transfer immunity, right, is it against a specific pathogen, for example, or a specific antigen or something, or is it a general immunity transfer?
I like this question very much, because this production is the art. IgY production, when we concern about its origin from the chicken, we can see how it is producing from in the serum, and then it passing through the serum to the oviduct line to the egg yolk. So it is passing the hostile environment and going inside the deep of the egg yolk. So it is naturally trained, because it is overcoming all obstacle and coming finally in the egg yolk. So from this point of view, this production in the animal also unique, but when we are collecting this IgY from the egg, and that production also included different types of interesting step, that before going to the production of the IgY, we are selecting the chicken as a species. So that's why the chicken is the natural biological factory of the IgY production. And we are this technology is showing this technique, that the target of the pathogen or antigen that is immunized in the chicken, which is giving the antibody response in the serum in the chicken, that is going to the egg. That high titer IgY containing egg is collected, and that egg is breaking to produce the egg yolk solution, and then pasteurization, and then it is going to the spray drying technique to make the powder, which is containing the natural formulation of egg powder. That means everything is nutrient value and its biological activity, IgY activity value, everything is intact. So every step it is following the several microbiological analysis and some technique for monitoring is quality also. That's why finally it is coming as IgY powder, which is the active ingredients, which will further used for as a feed additive for the formulation of the livestock food and the companion animals feed. Then when we are producing the IgY, we are also considering the different pathogen, and these different pathogens is coming from the different species. For example, pig, chicken, cow, they have the different pathogenic profile. So the IgY also produced specifically against that pathogenic, and also companion animal, there are some pathogenic profile for the oral disease and gastrointestinal disease. Also, it can produce the IgY from that specific pathogen from the component animal. Likewise, human. So that means IgY can produce separately from different pathogens and also used for controlling the different infectious disease of other animals.
So what is that? Maybe talking about advantages from IgY compared to other ways. So one advantage would be that obviously you can have an indefinite or indefinite amount of eggs, correct? So without any additional one. Or is this the major advantage? Are there other advantages compared to colostrum compared to other ways of antibodies?
There are several advantages of IgY. I will focus here some important advantages. Number one is non-invasive production, and also is high yield of the production. Number two is species-specific immunogenicity, and is reduce the immune response in mammals. Since IgY comes from the bird, it has a low immunogenicity in the mammals, making it as a safer alternative in the therapeutic and diagnostic application. Third is advantage is high stability, is environmental stability, is resistant to temperature, and also resistance, and also it is stable at pH 4 and 8, some acidic environment in the stomach, and it is also suitable for the oral administration and use in the harsh condition. And also there is a longer shelf life, is structural stability, giving this IgY is a longer shelf life in the ambient temperature. Then its therapeutical potential also, it can use oral therapy, and it is also used as an antimicrobial and anti-inflammatory activity also, and this is also applied in the veterinary application for the prevention and treatment of the animal diseases. There is also advantage from the ethical point of view, it's for the animal welfare, because it's coming from egg without killing the animal or disturbing the animal. And that is a finally we can say is the broad applicability in case of research and diagnostic. So if we like to compare the IgY with the other antibodies like the colostrum or blood plasma, we have to consider few parameters how it is superior than blood plasma or IgG. I will just point important some point I will share with you. That is, it can be customized. The customization for the tailor-made IgY is possible where other antibodies cannot, and its specificity is highly specific because it is developed against the specific pathogen where other antibodies is non-specific origin. Then its genetic selection, it is very important because repeated hyperimmunization creates a stronger antibody molecules. Is get well trained, well prepared, well know how to protect the organism against some imminent pathogen. So this is the comparatively stronger. It's coming from genetic selection theory. Then its molecular structures also is important, is bigger in size. Then its quality is always constant, not very variable like the IgG. And then this maternal antibody transfer mechanism also very important. We know the milk-based IgG provided daily to the baby for a longer time, like a few days to years. But in case of yolk-based IgY, it provided only once to the chick before hatching. So it is genetically stronger in nature. So that's why there is a IgY superiority of other antibodies also we can understand from this discussion.
Let me continue a little bit and ask a question about what are current applications? Are there current applications of IgY for companion animals specifically?
If I focus current application, then it will go only for its oral care treatment, oral care purpose. This is related to my first job or first project in IRIG, where I started this project and surveyed the literature for identifying the major pathogenic factors to develop this disease is called periodontitis in the dog and cat. Then, after long studies, it came to know that the gingipine enzyme is coming from this pathogen, is common for dog and cat. Even the species is different, like Performanus gingivalis, Performanus gulli, Performanus circumdentaria, and other species also. But they are common in one point: they are producing and secreting the enzyme gingipine for their survivability, for their propagation. So this gingipine, if we can target for the production of the antibody, then we can control this disease. If we come from the mechanism, how periodontitis is occurring in the oral cavity. First, this bacteria is anaerobic, so it likes to go the anaerobic area in the periodontal pocket in deeper side of the gingival tissue. So it needs to make the space by using the gingipine, and this gingipine is protease in nature, protein degrading enzyme. By this enzyme activity, gingival tissue is damaged, then it is going inside, then it is providing the nutrient source for other next coming biofilm microflora that is coming later on the oral cavity. So they are taking the food from Performanus gingivalis gingipine activity results, and this gingivalis is also propagating by enzymic degradations of its substrate, and it may make one microflora biofilm that is technically called is plaque and tartar and calculus. So my first antibody production is anti-gingipine IgY. Then I started to make its efficacy in vitro by enzyme activity. It significantly inactivated the enzyme activity in vitro. Then I used the mouse model for checking this in vitro efficacy that is based on the enzyme inhibition activity. Then I used the dog. In case of the dog, I designed one trial with a control and test group for 2 months application, and the parameters considered at the time, it was inflammation score, bleeding on probe, periodontal pocket depth, and Performanus gingivalis count, halitosis, and is overall body weight gain. So everything after 2 months, 8 weeks of application, we analyzed, and it is shown that anti-gingipine IgY is significantly inhibited the growth of the pathogen, then also inhibited the adherence of the Performanus gingivalis to the gingival cell, because the inflammation score is reducing, which is linked to the halitosis, because inflammation is giving the damage of the tissue, giving the bad smell, and that prevention of adherence is the gingival tissue is intact, healthy, so halitosis is reduced. So there are important things is that we have taken the photograph of a specific teeth. After 2 weeks, when we considered, then interestingly, out of 10 tested dogs, 3 dogs calculus tartar completely removed from the molar teeth. It is not the premolar or incisor. If it is the in front teeth, we can say it is coming from playing with the cage or something. But no, it is the deeper side, the molar teeth. It is loosening the tartars and removed. We understood when we analyzed the photograph taken at the time. So this is also interesting mechanism behind why it is plaque is removed. I faced some question when I presented in the veterinary conference seminar. Then I explained, because there are 3 factors is working here. Number 1, gingipine is inhibiting the enzyme activity, so the species of the Porphyria gingivalis is reduced. It is lower infective dose, number 1. Number 2, for that reason, the other microflora of the biofilm, they are lacking their food, the nutrition scarcity over there, and quorum sensing is disorder. So the plaque is not well developed. And number 3, there are always saliva is secreting. There is a physical reaction also there, chemical reaction also there, biological reaction there. These combined reactions ultimately loosening the tartar and removed completely from the teeth surface. That's why, to my knowledge, this is the only product that these anti-gingipine IgY supplemented pet food is reduce the plaque and tartar very efficiently. Not only my study. After my study, other group also is also proved scientifically, and they also reported in the article.
Perfect. So the beauty of IgY is that you can target different molecules. It doesn't always the pathogen. So enzyme is one thing. Are there any other applications that you are working on in the companion animal space?
The companion animals also affected by virus and bacteria, especially in the gastrointestinal infection. In case of the gastrointestinal infection, our IRIG group first reported the anti-canine parvovirus IgY, which is experimentally we proved in vitro is activity and cross reactivity with a variety of parvovirus strain, which is globally circulated. So this is we proved repeatedly, and this is also cat canine parvovirus, and it's also effect for the feline parvovirus for dog and cat also. So there are also some in vivo study where the parvopositive dog also is applied dose-dependent manners, the anti-canine parvovirus, which is ultimately shows that minimize the excretion of the virus from the stool sample, and their fecal scoring also very good, which is linked to their body weight gain. So it is recovered the parvo infections very efficiently by anti-canine parvovirus IgY. Not only that, there is another pathogen that is coming from protozoa. We call it Giardia lamblia. This also our IRIG team first demonstrated this anti-Giardia lamblia IgY. We know this is the flagellated. It is moving 360 degrees in the intestine, so it is very dangerous when the intestinal infections is coming from canine parvovirus and other co-infections, and Giardia is there. So it is giving the very dangerous situation in the intestinal area. So when we develop the anti-Giardia IgY and put in the in vitro slide tested by this Giardia IgY, unbelievable this the movement after adding the IgY in the slide, within 10 seconds, the movement is totally stopped because it is efficiently block the movement by antigen and antibody reaction. And also there is a in vivo mouse trials also conducted, and the total results also indicate that it was really the good protective effect against experimentally induced some giardiasis in mice. And other pathogen also reported till now, like E. coli, Clostridiums in the young puppies and kitten.
We are almost at the end. We are coming to the end of our episode. So, I mean, so with other words, you see the excitement. I think so. There's a lot of applications of IgY, right? Because theoretically, you can target everything. If you can summarize for 1 minute, because we're almost at the end, for 1 minute, what is the future? What is your future research? Is it trying different diseases? Is there something that else you can optimize with IgY, or which big areas you can target? But just really brief summary.
The future IgY research, we are, or the scientists are now focusing the pet obesity, which is a mechanism is that the lipase enzyme is responsible for digestion of the fat and absorption in the body. So anti-lipase IgY can block or control the enzyme activity so that it can manage or control the pet obesity. This is the one future research. Another one is the complementary strategies to reduce the use of antimicrobials by using IgY effectively. And also the future IgY research can use for alternative of antimicrobial resistance microbe. I like to say that it is so flexible technology, IgY, that we can do the future research in various purposes when it is needed.
If you want to give us maybe one final statement, what keeps you excited beyond IgA? Is it so that our younger audience, gets the same enthusiasm like you do for research? What keeps you excited?
My most beloved young generation scientist. Actually, I like young generation scientists because our work that we are doing, it will be continuing with the next generation. So we have to take care from all sides. So I have some message for them. I like to quote one sentence from the Albert Einstein, that I am neither especially clever nor especially gifted. I am only very, very curious. So the curiosity is the foundation of all great scientific achievement in this world. So if, my beloved scientist, you are curious and with the passion, you will be succeed in the long run, I believe. And I just share my personal experience from my life when I was in grade 9 student joining in the biology class. At the time, my teacher is explaining about the teeny mysterious world where is we cannot see that types of living being microorganisms by eyes. It needs the microscope. So that was driving me to study the microbiology. That I am standing now on that basement, and my career also is going on that direction progressively. So always be positive and improve your quality. The quality is never an accident. It is the result of your accumulated endless intelligent effort. If your qualities improve, that means your confidence also improve. And self-confidence is the miracle worker of your life. So self-confidence is very important. So your passion is very important here. my beloved young scientist. So my passion, I have come back to me, my passion for understanding the microbiology of diverse species gave me the focus I needed through my academic university life and the foundation that prepared me for the job of my dreams.
Thank you so much. Those are very great words.
Thank you very much.
Thank you, Shofiqur Rahman, for really this very enlightening. I think IgY is really a very promising application. I think there's going to be probably a lot of new information, new applications are coming from. So I'm really excited about what you shared today with us, because I heard about it, but I think I now much better understand all the applications that we can use in the future. So with this, thank you so much. And that concludes another episode of the Pet Food Science Podcast presented to you by Wise Genetics. Thank you for joining us today. Please sign up for follow-up episodes. And until next time, my name is Jan Podolski from the Pet Food Science Podcast, signing off. Talk to you later. Bye-bye.
Goodbye.